All right. So this is a lesson on 8.1. All right, let's kind of move through it really quickly. And so this unit is on circuits, right? That's in this entire unit. For electricity to flow, well, electrons have to kind of go through wires, right? Go through metal. There must be a path. And really, they go through circuits. I want to call them circuits. And the image you see on the right-hand side is an image of a simple circuit, right? So a simple circuit has a battery, right? It has a switch and it has a bulb, right? And so when you turn on the switch, flip the switch, well, you're gonna light up the bulb. And the first thing we'll learn about electricity is, well, we're gonna talk about electron flow, right? That's something called electric current. Well, how many electrons flow through a given part of wire at any given point in time? Right? So electric current really is about, well, how fast, or right, how many electrons to flow through a certain part of the wire at any given point in time. Right? So if you ever see any of the wires outside your home or outside on the street, you see those poles, right? These wires help electrons flow through them, so electricity can be delivered to your home. That's why your computer is on right now, right? That's why your laptop is on right now, right? That's why you have any form of electricity, is because electrons flow through these wires. And so the formula for electric current is delta Q over T. Right? So it's delta Q over T is your amount of charge that flows through a given wire over a period of time. And on your reference table, it's right here. It's the fourth formula down on the electricity page, right? So it's this fourth formula down. And so I is going to be your electric current, and electric current is measured in amps. And Q is going to be your electric charge measured in coulombs. And T is going to be time, which is measured in seconds. And so if you look at the bottom right hand GIF, right, so you know that, well, the more electrons you have, the larger electric current. And the fewer electrons you have flowing through a wire, the smaller your current, the smaller your electric current is. So let's take a look at this practice question right here. Right, so your electric current is 5 amperes, right? That's 5 amperes. And your total amount of charge, and when you calculate it, that flows through the wire in 36 seconds, right? So we're gonna use this formula, this delta Q. The delta Q doesn't matter. The delta Q is important past Regents physics, but it's not important to you guys, right? So we're just going to treat Q as really just something. So my I is 5, my delta Q is delta Q, that's what we're going to solve for, and my T is 36. I'm going to multiply by 36 on both sides, so 5 times 36 gives me 185 times 6, 210. No, that doesn't seem about right. Well, 5, 4, 180, I'm sorry. I don't understand why it took such a long time for that. But either way, 180 coulombs is the amount of charge that's flowing through the wire, right? And you see that on the slides here. So here in this next problem, you see something called a resistor, right? A 207 ohm resistor. But a resistor really is just anything that has electricity flowing through it, right? Your laptop, a computer, a phone, a lamp, a light bulb, a TV, anything that has electricity running through it is a resistor. I'm going to call them resistors. But that part is not important for now because we're going to talk about that in 8.2. So reading this problem, electric circuit draws a current of that. So you have a current of 2.4 milliamps. And the total charge that passes through this resistor in 15 seconds is what, right? So you have a time of 15 seconds. And well, you want to know, well, what is Q? What is Q? First thing we're going to do here is we want this unit in amps, right? But my unit for current is in milliamps. Well, we know according to your reference table in the first page, well, 1 milli is equal to 10 to the negative 3. And so your electric current here is 2.4 times 10 to the negative 3 amps. And again, you're just really just going to use this formula right here, and you're going to solve it the same exact way. Now we get to 3C. So 3C says, well, you have in this conductor, whatever it is, we have 3.15 times 10 to the 18 electrons. But electric charge Q is measured in coulombs. So we have to convert the amount of electrons we have into electric charge, but we know that one elementary charge has 1.6 times 10 to the negative 19 coulombs. And so 3.15 times 10 to the 18 of those, well, what we're going to do here is going to multiply this number, right? We're going to multiply that number by this, because we want to know, well, what is my total charge? And we should get a number of, I'm just going to cheat a little bit. I'm going to look forward. It's 5.04 times 10 to the negative 1 coulombs. And so that's my electric charge. And it flows through this conductor in 10 seconds, and they want to know what your current is, right? So you really, again, you're going to use that formula. Really, the only tricky part here was converting your electric charge into coulombs, right? You want to do that. And you're going to do the same thing for 3D as well, right? And that's essentially this lesson, right? Make sure for 3E gives you minutes, right? They give you minutes in terms of time. Really just convert that to seconds before you do anything, okay?